Hello, I am Dr. C. Mohan. Today's topic of discussion is matrices. See, let me define what is a matrix first. A matrix is a rectangular array of elements. In other words, we can say a matrix is the arrangement of elements in rows and columns. By elements we mean normally the numbers. Okay, let me give an example. A is equal to, I'll write here 1, 50, 40, 100, 25, 28, 75. Now here I will say that this is a matrix. It gives a picture of the runs scored by players. Let me say the player 1 and player 2 and matches 1, 2, 3. There are 3 matches held and the 2 players 1 and 2. One has scored in the first match 50, second match 40, third match 100. Second player scores 25 in the first match, 28 in the second match and 75 in the third match. This is a matrix. This gives a complete picture of the runs scored by the players, and you can evaluate the capacity of the player using this matrix. Now you can see that there are 2 rows in this, and there are 3. This is row 1 and this is row 2 and column 1, column 2, column 3, and this will be called as A is a 2 cross 3 matrix. Now you see that elements are arranged in rows and columns, and therefore a matrix is an arrangement of elements in rows and columns. So this is what we should understand first initially as matrix. Then in the place of we normally write A is equal to Aij of M cross n. Normal representation. See, this is the normal representation of a matrix. A is equal to Aij M cross n. This means that the elements of this matrix A or Aij's, every element is an Aij, and that there are M rows and n columns. Let me give a specific example of this. A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Now you see that I'll put it like this. Now this is a matrix. There are 3 rows and 3 columns. We say that A is of order 3. We say A is a order 3, that is, it is a 3 cross 3 matrix, and that is 3 cross 3 matrix called the square matrix. So what is a square matrix? A matrix wherein the number of rows is equal to number of columns, and such a matrix is called as a determinant. What do we call that? We call a square matrix also as the determinant. Determinant in the sense A is determinant of order 3. So this is what the meaning of a matrix. And a matrix with m cross and m rows and n columns, if it so happens that the number of rows is equal to number of columns, then we call such a matrix as the determinant. Okay. Now, let me give some types of matrices. Some types of matrices. Now, one or two I will give you. Say, I'll write here. Now, what is that you find here? There is only one row. That is why you put is what? A11, A12, A1n. See, the first suffix refers to the row. Second suffix refers to the columns. Here you see that there is only one row, but there are n columns here. Therefore, this is called a column matrix. This is a row matrix. And B is equal to A11, A12, dot, 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 A1n. Now, what is that you find here now? There are n rows, but only one column. So, this is a n cross 1. This is 1 cross n. In the sense, this is a column matrix. This is a column matrix. And I'll write here this is a unitary matrix. You find this one along the principal diagonal. This is called a principal diagonal. You find one along the principal diagonal and 0 elsewhere. This is called a unitary matrix. And this is a unitary matrix of order 3. Likewise, I can write O is equal to now this is a 0 matrix. This is a 0 matrix of order 3. Of order 3. That is, this is a square matrix of order 3. Zeros everywhere. These two matrices are very, very important, because when we are going to deal with higher applications of matrices, this idea of this I and O will be widely applied. So, note down that these two matrices are going to play an important role in the coming days of teaching in the teaching of matrices. Okay. Now, some more examples I will give you. Now, I have written two matrices. Just watch. I have written two matrices here. Here you find that the element first row second element is equal to second row first element. First row third element is equal to third row first element. Second row third element is equal to third row second element. See, what I mean is that here you find that Aij is equal to Aji for all ing. This means for all. So what is it you find here? You find that this property of Aij is equal to Aji in this A matrix. Such a matrix where this property of Aij is equal to Aj holds good, then we say that A is a symmetric matrix. So what is a symmetric matrix? A symmetric matrix is one in which Aij is equal to AJI for all I and j. This is a symmetric matrix. And symmetric matrix has to be a square matrix. Symmetric matrix has to be necessarily a square matrix. So you see that's symmetric. Symmetric matrix. Now let me take the next one here. Now what is that you find here? B matrix. What is that B matrix? What is the difference that you find? I will write here your Aij is equal to minus Aj for all I and j. Now what is that you find here? Here A12 is equal to minus A21. What is it you find here? A12 is equal to minus A21. A13 is equal to minus A31. A23 is equal to minus A32. Now you see that here it so happens that the element of A12 is a minus of the element of A21. Likewise, A13 is equal to minus A31. So a matrix in which this particular property holds good or this feature happens, we call such matrix as a skew symmetric matrix. What is it called? It is called a skew symmetric matrix. And again, understand that it has to be a square matrix. So, symmetric matrix or a skew symmetric matrix has to be necessarily a square matrix. And the property is that in the case of a symmetric matrix, it is Aij is equal to Aji. In the case of a skew symmetric matrix, it is Aij is equal to minus Aij. So, this is a particular case of a matrix. Okay. Now, I'll introduce another type of matrix. Consider this. A is equal to 1 I 2 plus I minus I 3. I'll write here Now I have given you two matrices. See, before explaining this, what is the idea about these two matrices? To give a knowledge about these two matrices, I should give you the knowledge of what is I. What is I? I value is square root of minus 1, which is an imaginary. See, its value is not known. We do not know. Square root of minus 1. It is called, but such numbers do exist. Okay. So, such numbers are called the imaginary numbers. See, this is imaginary number. It is an imaginary number. Therefore, any number of the form A plus IB is imaginary number or complex number. So such numbers will be called as a complex number. And here I'll write here, and if A plus IB is a complex number, A minus IB is its complex conjugate. So what is that I have given you just now? I am giving you an idea of what is a complex number. A complex number is a number which has an imaginary part. The imaginary part is understood by the presence of the letter I. What is that I? I is equal to square root of minus 1. So if a number is given along with this I, such numbers will be called as a complex number. For example, here in this matrix, 2 plus I is a complex number. 0 plus I is a complex number. And here, therefore, generally any number of the form A plus IB, where A and B can be any real number. A and B can be any real number. So A plus IB will be called as a complex. The general representation of a complex number is A plus IB, where A and B are real numbers. If one more concept that should be that is of indispensably should be known by students is, if A plus IB is a number, then we call it as complex conjugate. Conjugate of A plus IB. Conjugate of A plus IB will be simply change this plus I to minus I. Okay, change this sign plus to minus. That is, if it is plus I, change it to minus I. If it's minus I, change it to plus I. So if A plus IB is your complex number, its conjugate is A minus IB. If A minus IB is your complex number, its conjugate is A plus IB. So this concept should be well understood. I am going to use that idea here to explain these two matrices. I will give you the name of these two matrices after giving an explanation. Okay, now I'll remove this for my convenience sake. Now here, as I explained to you in symmetric matrix, bring that idea of symmetric matrix. The second element is A11. See here, I'll put it here. For this, A11 is equal to I, but A12. A first row second element is I, and second row first element is, what is the, see, you can write this as 0 plus I. What is the conjugate of this? Simply change this 0 to plus to minus. 0 minus I. Can you say this here? So here A12 is 0 plus I. A21 is 0I. So what is that you find? A12 is equal to A21 complex. See, this bar over A21 mentions refers to a conjugate number. So A21 is its conjugate. A12 is equal to its conjugate number. So if A12 is a imaginary given complex number, then A2 only will be its conjugate. Now can you see? Now let me come to what is A13. A13 is 2 plus I. Now what is A31? A31, so it is not equal to, you can just say that if A21, see, I will write it here, A12 is I, A21 is equal to its conjugate minus I. Now let me come to this. A13, what is your A13 here? 2 plus I. What is its conjugate? A13 bar is equal to 2 minus I. You are getting 2 minus I here. A131, yes. Now come to A23. What's your A23? Minus I plus 4. Now A32. What is the conjugate of this? Change this minus I to plus I plus 4. See? So in a matrix, if the elements are such that Aij is equal to Aij bar, Aji bar. Aji means what? If Aij is equal to Aji bar, here if Aij is a complex number, then it is equal to what? Then if Aij is a complex number, then Aji is conjugate of Aij. So if Aij is a complex number, then Aji must be its complex conjugate. If this pattern follows in the given matrix, which is also a square matrix, then we say that such a matrix as this will be called as a Hermitian matrix. This will be called as a Hermitian matrix. Now, so it is similar to your symmetric matrix. In the sense, if Aij is equal to Aji, then it is symmetric. If Aij is equal to minus Aji bar Aji, it is a skew symmetric. In Hermitian matrix, if Aij is a complex number, Aji will be the complex conjugate of that. If this happens in a given square matrix, then that will be called as a Hermitian matrix. Now bring the similar idea I taught about this skew symmetric to this matrix. What is this matrix? Can you see this here? What is this? A11 is equal to I. Now what is the conjugate for A12? A12 is equal to I. Now A21, what is the complex conjugate of this? Minus I. But you multiply this by minus sign. What I mean is that if A12 is your conjugate, a complex number, then A21 must be minus of that conjugate. If I is the number, complex number, its conjugate is minus I, multiply that by minus sign. So what is that you get? Here minus sign means I. So your A12 is equal to A21, which is nothing but minus of the conjugate. Another one I'll tell you. See, here I will just rub it off here. For this, now what is your A13? A13 is equal to 2 plus I. Now let me come to A13, come to A31. A31 is minus 2 plus I. Now what I mean is, what is the conjugate of 2 plus I? Conjugate of this 2 plus I is 2 minus I. What is the conjugate of 2 plus I? 2 plus I is, see conjugate, I'll write here. Conjugate of 2 plus I equal to 2 minus I. Now multiply this by minus sign. So what is that you'll get? Minus 2 minus of 2 minus I. That is minus 2 plus I. That is what you have here, minus 2 plus I. So if it so happens that if Aij, so what is generally, so what is that you must understand? If Aij is a complex number, then Aji is equal to minus of Aij bar. Aji must be equal to what? Minus of Aij conjugate. If this pattern is followed in that particular matrix, then we call such a matrix as, there you called it as skew symmetric, here you call it as skew Hermitian. So what is this called? This is called skew Hermitian. Skew Hermitian. So what is that I have taught you now? What is the symmetric? What is the skew symmetric? Coming to Hermitian, Hermitian matrix is also a square matrix which has complex numbers in it. If in the given matrix, if Aij is equal to, or if Aij is a complex number, then Aj must be the conjugate of Aij. If this pattern is followed in that matrix, then it is called a Hermitian matrix. If it so happens that in the same matrix, if Aij is a complex number, Ai is nothing but minus of negative of the conjugate of Aij, then such a matrix will be called as a skew Hermitian. See, can you see here? I plus 4, what is the conjugate of this? I plus 4. Multiplied by minus sign, it is minus I minus 4. So, matrix wherein if the complex if Aij is equal to minus of Aij bar, then that will be called as a complex skew Hermitian matrix. Now, let me come to a very important concept of transpose of a matrix. See, if A is equal to 1, 2, 4, 5, 7, 8, this is a 3 cross 2 matrix. Transpose of A is A dash. Change rows to columns and columns to rows. What is this row? Change it. This is a row, change it to column. This is a row, change it to column. This is a row, change it to. Now what is that you find here? This is a 2 cross 3. So if it is a 3 cross 2 matrix, transpose will be a 2 cross 3 matrix. If it is an M cross matrix, M cross N matrix, then A transpose will be what? N cross A matrix. So if A is an M cross N matrix, transpose will be change rows to columns and columns to rows. In which case, if it is an M cross N matrix, M rows and N columns, transpose of it will be N rows and M columns. Okay. Now these are now addition of two matrices. If I given you two matrices. A is equal to Aij M cross N. Bij is M cross N. Now you see that these two matrices are of same order, M rows and N columns. Now you can add these two matrices. That is, A plus B is possible, and this is nothing but Aij plus Bij. Add the corresponding elements and it will be M cross N, and you can find that this is also equal to B cross B plus A. A plus B is equal to B plus A. That is true, because you will find that it is true. Okay. Now, if A is equal to Aij M cross N, B is equal to Bij N cross B. What is that I have written here? A is a M cross N matrix, whereas B is a N cross P matrix. You find the number of columns here is equal to number of rows here. If you have two matrices, wherein the first matrix has got M rows and N columns, second matrix has got N rows and P columns, the number of columns here is equal to number of rows, then you can multiply the two matrices. That is, A into B is possible because number of columns in A is equal to number of rows in B. Here it is what? N, and here also N. So multiplication of two matrices is possible only when the number of columns in the first matrix is equal to number of rows in the second matrix. And note that A cross B need not be equal to B cross A. A cross B need not be equal to B cross A. It will happen only when they are of the same order. If they are of the same order, then naturally A cross B can be equal to B cross A. But otherwise, it is not possible. So this is the idea about the matrix addition and matrix multiplication. I will teach you how the multiplication is carried out in the case of two matrices with simple example. Okay. See, if let me take A is equal to 1, 2, 4, 5. This is a 2 cross 2 matrix. I'll take B is equal to 2 rows and 2 columns. Now what is that you find here? 2 rows. How many rows are there? 2 rows and 2 columns. Here number of columns is equal to number of rows here. 2 rows, 2 columns here, 2 rows here, number of columns 3. Now I can multiply these two matrices because the condition is satisfied. Namely, the number of columns in the first matrix is equal to number of rows in the second matrix. Now I'll take this. See, A into B, 1, 2, 4, 5 into minus 1, 4, 1. So when you multiply row into first row into first column plus 1 into minus 1 plus 2 into 0. First row into second column. See, 1 into 4 plus 2 into 5. First row into third column. The same methodology must be followed in the case of multiplying the second row with the columns. That means second row into first column, second row into second column, second row into third column. So the same operation must be carried out. That is 4 into minus 1 is minus 4, 5 into 0 is 0, so add minus 4. 4 into 4 is 16, 5 into 5 is 25, 25 plus 16 will be 31, 41 it is. 4 into 1 is 4, 5 into 1 is 4, 4 plus 5 is 9. So what is that you find? 1 into minus 1 is minus 1, 2 into 0 is 0, so it is minus 1. Then it is minus 4. 1 into 4 is 4, 2 into 5 is 10, so it is 14. And it is 41. This 1 into 1 is 1, 2 into this is 3, and it is 9. So this is how the multiplication of matrices is carried out. Okay? Now you tell me whether B cross A is possible. B cross A, if you take, it is B is 2 cross 3 multiplied by, it is 2 cross 2. Now you see that the number of columns here it is number of, they are not equal. The number of columns here 3, the number of rows 2, so they cannot be multiplied. So it is possible only when the number of columns in the first matrix is equal to number of rows in the second matrix. Now I have taught you now how the multiplication is carried out. Then important point I will tell you, if A is 1, 1, 2, minus 1, 4, 0, 1, 2, 1. A is a 3 cross 3 matrix. It is a determinant in the sense the number of rows is equal to number of columns. Now we can determine the determinant of A. That is, we can determine the determinant of A. So if a given matrix is a square matrix, then we can find the determinant of A. How the determinant of A is found, I'll use this problem to explain. See, the real method of doing it I can teach, but I will give you an example so that you can understand better. And if the theory is taught after then, your understanding will be better. So I will give you the example to understand how the determinant value is found. Okay, now I'll write here is equal to, see this I will write here 1 into see this 1 multiplied by, suppress this row and suppress this column, this is your 4021. So then you write minus 1 multiplied by, suppress this column, suppress this row, so you'll get minus 1 0 1 1 plus alternate plus minus like that it must go. So 1 plus 1 plus minus then again plus. Here it is 2. Suppress this column and this row, you will get it as what? Minus 1 4 1 2. Now 1, how to get the value of this? This you have to multiply this first and then these two. 4 into 1 is 4 minus 2 into 0 minus 1 into minus 1 into 1 is minus 1 minus 1 into 0 is 0 plus 2 into minus 1 into 2 is minus 2. It is minus 1 into 4 is 4. So this is 4 minus 0 is 4. This is minus 1 into minus 1 is plus 1. This is minus 6, so minus 12. So this is equal to minus 7. So what is the determinant value of this matrix A? It is equal to minus 7. This is how we find the determinant value of a square matrix. And A is equal to 0 means A is singular matrix. Modulus of A not equal to 0 implies it is non-singular. So it is a non-singular matrix. Now, so I have taught you just now, given a square matrix, how to get the value of the matrix, in the sense, how to get the determinant of A. For that, what you have to do is, take the first row, anything you can take. You can take first row, second row, third row, first column, second column, third column, no problem at all. But understanding in a without really understanding the theory part of it, just to know how to do that, the method of doing it is, take the first element, it is positive. Suppress this column and suppress the corresponding row, write the other matrix. What is this matrix? 4 0 4 0 2 1. Likewise, the next one must be negative. Minus. What is the number here? 1. Suppress this column, suppress this row, minus 1 0 1 1. Then plus. So plus, minus, plus, minus, plus. So here it is plus. And what is that number that which you have to multiply? 2. Into, what is the matrix here? Suppress this column, suppress this row, so you will get this. So this is, and this is the method of doing it for any order of any order of matrix. The determinant may be even n cross n, but for getting the value of determinant of A, the same method must be applied. Here, either I told you, go with the first row or second row or third row, first column, second column, third column, no problem at all. But the thing is, you must understand that if this is here, plus, minus, plus. Suppose you are going to expand using this middle row. See, here if you come here, it will be minus, plus, minus. So, you see that there is a method of doing it, but go always by the first row so that it will be plus the element into its submatrix minus the element into submatrix plus the element into submatrix. So this is how we do it and get this thing. Now here I want to just make a mention of one particular idea, that is this particular matrix that you have got here, 4021 minus 1011, they are all called the minors, M-I-N-O-R-S, called the minors. Called the minors or submatrix. We call them as submatrices, or we can call them by minors. So here in this particular case, you can write this as, see here you can write, I'll rub off and write. So this can be written as, see, your first element A11 into its M11 minus A12 into its minor plus A13 into its minor. So this is the way that you write here. A11, M11. A11 is here 1. A12 is 1. A13 is 1. So this is A12, this is A11, 2 is your A13. A11 into its minor, A11, M11, A12, M12, A13, M13. So they are called the minors of the matrix. So have this in your mind. We are pausing on to a very, very important aspect of finding the inverse of a given matrix. How to get the inverse, that is given A. What I mean is that I'll rub off this. See, if A is a square matrix, then A minus 1 will be called as inverse of A. This has got the same idea as in numbers. It's a very simple idea. Suppose 2 is a number. What is the inverse of 2? Multiplicative to inverse. So 2 into 1 by 2 is equal to 1. This is called the multiplicative inverse. If 2 is a number, its inverse is half. So that this. So likewise, if see A is a matrix, A minus 1 is its inverse. So A into A minus 1 must be equal to A minus 1 into A. 1 means it is, if it is a number, it is 1. But here we are dealing only with matrices. So this has to be a unit matrix. Unitary matrix. So if A is a given matrix, square matrix, I can think of finding the inverse of A. That inverse of A will be denoted by A to the power of minus 1. And that A to the power of minus 1, how to you find the value of A to the power of minus 1? But how are you sure that it is the inverse of A? The simple verification is multiply A and A minus 1 in any way that you multiply. For example, A into A minus 1 or A minus 1 into A, it will give you a matrix. That matrix is unitary matrix. As I told you here, 2 is a number, half is its multiplicative inverse, multiply you will get 1. That it is a number. But in the case here it is a matrix. So the resulting matrix must be a unitary matrix. Have this in your mind. Let me take a very important problem here. Now, to find A minus 1 given A minus 1 given A. Let A is equal to so you are given A by A. Find A minus 1 given A. What is that A? A is given A is 1, 2, minus 1, 4. How to get this? See, formula. First, I'll write the formula. So what is the formula? Adjoint of A divided by determinant of A. Adjoint of A is equal to cofactor matrix. I'll tell you this. Cofactor matrix of A. Take the transpose of it. Take the transpose of it. Now, I'll write here. So you have got this 1, 2, minus 4. See, A given. See, 1, 2, minus 1, 4. So right here. See, what is the meaning of cofactor? Means cofactor of every element in the matrix. By this, see, I write it here. Cofactor of 1. What is the cofactor of 1? Cofactor of 1 is equal to, see, suppress this column, suppress this row, write the minor. See, it is equal to, always the formula is minus, see, I write it here, 1. What is that element? A11. So this is equal to minus 1 to the power of 1 M11. Can you write here? See, can you understand here? This is your A11. So cofactor of A11 will be equal to minus 1 to the power of 1 plus 1, that is into its minor M11. I taught you about minor. So this is a minor. So, and cofactor of 2, which is that element here? A12 minus 1 to the power of this into M12. Cofactor of, what is this element? It is minus 1, which is nothing but A21, which is equal to minus 1 to the power of 2 plus 1, A21. And cofactor of this is 4, which is A22 minus 1 to the power of 2 plus 2 into its minus. Now let me find out this. Now come to this. Minus 1 to the power of 1 plus 1 is 2. Minus 1 squared is what? 1. So this is 1 into. What is M11? I taught you what is the meaning of the minor. How do you get the minor of an element? Suppress. Suppress means just give up that. Suppress means give it up. So give up that particular row or column of that matrix and take the rest. Okay? Take the rest. Take the rest. It is a matrix, a minor. Okay? It is called a submatrix. Now come to this. 1 is here. Suppress this column. Suppress this row. You will find this M11 is nothing but 4 itself. It is a singleton. It is a matrix with single element. So this is a 4. So this is equal to 1 into 4. That is equal to 4. Come to this. A12 minus 1 to the power of 1 plus 2 minus 1 to the power of 3. Minus 1 cubed is minus 1. So it is minus. M12 minor means what? Take this element, suppress this column, suppress the row, you will get what? Minus. So it is minus of minus 1, that is equal to 1. Okay, yeah. Then come to the next one, A21. What is your A21 here? A21 is minus 1 to the power of 2 plus 1. 2 plus 1 is 3. So it is again minus. What is your M21? It is minus 1. So minus 1 into minus 1 will be plus 1. So minus into minus 1 plus 1. Okay. So this is, so I will explain once. So this is 1 plus 1 square into 4. Come to this is A12 minus 1 to the power of 2. It is M12 is minus 1. So minus into minus is plus. Come to A21, see here, A21 is, A21 means minus 1 to the power of 2 plus 1. Here it is minus 1, this is minus, minus into minus is plus. Come to the fourth one, this is your A22 minus 1 to the power of 2 plus 2, 4, minus 1 to the power of even number is plus, M22 is what? It is, what is the minor of M22? It is equal to 1. So 1 into 1, that is equal to 1. So the minor of this is 4, minor of 2 is 1, minor of minus 1 is 1, minus of 4 is 1. Now I can write the cofactor matrix. Now I'll write here. See, what is your cofactor matrix? Cofactor matrix is equal to, see, it is 4, 1, and again it is 1, it is minus 1, it is 2, it is minus 1, see, A11, 1, 4, 2, it is minus 1 plus 1, it is minus 1, it is minus 2. And here it is 4 means 1. So this is. Okay. So 4, 1 minus 2, 1 is your cofactor matrix. That means finding the cofactors and forming a matrix. Now adjoint of A is equal to cofactor matrix, take the transpose. Take the transpose of, that is 4, 1 minus 2, 1. Take the transpose of this. What is the transpose of this? Change rows to columns. That is enough. So what is this row? 4, 1. What is this? Minus 2, 1. So what is that you have got? So the adjoint of A is 4 minus 2, 1, 1. Now what is your A determinant? What is your determinant of A? I taught you what is the meaning of determinant of A. 1 into 4 minus 1 into 2. So 1 into 4 is 4, minus 1 into 2 is minus 2. So minus into minus plus. So 4 plus 2 is 6. So what is that you have got? We have got the two, this thing. Now A minus 1 is equal to adjoint of A divided by modulus of A. Now adjoint of A is 4 minus 2, 1, 1 divided by 6. So we have got the results. What are the results that we have got? We have got the value of this determinant and also the adjoint of A. Therefore your A minus 1 is this. So I will write now here A minus 1 is equal to 4 by 6 minus 2 by 6, 1 by 6, 1 by 6. Now we have got the value of a minus 1. But I told you while talking about or giving a lecture on a minus 1, you will get the value of a to the power of minus 1. But how to verify whether you have got the right answer for a to the power of minus 1? For which I told you the verification is multiply a and a minus 1 or a minus 1 into a. The resulting matrix must be a unitary matrix. Unitary matrix in the sense, I told you what is a unitary matrix. It's 1 0 0 1. Just refer to my lecture back. You will find that by unitary matrix I mean 1 0 0 1, which is of order 2. So here, if I deal with A is a 2 cross 2 matrix, naturally my unitary matrix must be 2 cross 2. If I deal with a matrix with 3 cross 3, my unitary matrix will again be a 3 cross 3 matrix. So here in this particular case, since we are dealing with A, which is a 2 cross 2 matrix, A minus 1 is also a 2 cross 2 matrix. Naturally, I multiply these two, then I must definitely get my unitary matrix, which must be a 2 cross 2 matrix. Okay. Now let me verify. With that, let us close down this session. Okay. Now, A verification. A minus 1 is equal to, what is your A? 1 2 minus 1 4 multiplied by 4 6 minus 2 by 6 1 by 6. Now multiply. I told you how to multiply. First row into first column, 1 into 4 by 6, 2 into 1 by 6 is, so 4 by 6 plus 2 by 6 is 6 by 6. Then 1 into minus 2 by 6, 2 into 1 by 6 is plus 2 by 6. Multiply this, minus 4 by 6 plus 4 by 6. Multiply this for 2 by 6 plus 4 by 6. So this is what you have. So 6 by 6 is 1, this is 0, this is 0 and this is 1. Now you get unitary matrix of order 2. Verify now. A minus 1 A. What is that you get here? 4 by 6 minus 2 by 6 . 4 by 6 into 1 by 6. This is 2 by 6, so it is 1. This is 8 by 6 minus 8 by 6, 0. This is 1 by 6 minus 1 by 6, 0. 2 by 6 plus 4 by 6, 6 by 6, that is 1. Now you see that is A minus 1. A minus 1 is equal to I. So the inverse that we have got is absolute and it is correct. And so today I have taught you the meaning of matrix, some examples of matrix. Now and then I taught you what is called inverse of a matrix, that is the transpose of a matrix, the method of multiplication of two matrices, what is a square matrix, and what is the determinant of a matrix of the square matrix, and what is a singular matrix and non-singular matrix, what is a cofactor, and how to find the inverse of a matrix. With this broad idea about matrices, we can pass on to higher level of matrices, which will be dealt in the coming classes. Thank you.